Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video, and today's video is about another interesting topic in 8051 microcontroller. We're going to see how to generate square wave using timer programming. In previous video we have seen how to generate delay through timer programming, and today we're going to see how to generate square wave. And before starting this video, right, I have already said for timer programming, you got to understand the basics of counter, how it operates, when it works as a timer and when it works as a counter, right, and how to configure TMOD and TCON register. All those are very, very important, right? So please go back through the previous videos, right, so that you can understand the basics about the timer programming, the TCON and TMOD register, so that you can easily understand this video, right? So we will start with this particular timer programming. Before seeing this timer programming, you have to understand what is TMOD register and TCON register. I'll just quickly refresh that. We know that whenever we want to configure a timer, that is, we know that timer will work as a timer and as well as counter, right? If timer is using the internal clock pulse, it is used as a timer, and if it is using the external clock pulse, it can be used as a counter, correct? Right, and I have already explained this TMOD register, but before programming, once again I'll explain. These two bits tells you what is the mode of operation that we have to work, right? And we know that we have four different modes: mode 0, mode 1, mode 2, mode 3, and I have already explained how these modes works in previous video, right? And this bit, we know the importance of this bit, C by T, that will tell you whether it is working as a timer or a counter. When C by T is equal to 0, it is working as a timer. In C by T is equal to 1, it will work as a counter, right? And you know what is the operation of gate, right? Whenever we use an external clock pulse, we have this gate, right? And for counter operation, this gate will be 1, right? And it will be cleared for timer operation. It will be 0, correct? All these things we have already seen, right? And similarly, there is another important register, which is TCON register, which controls the timing operations, right? As I said, which timer we have to select, which overflow will happen. All these things will be controlled by the TCON register, right? And I have already explained this, but once again, I'll just refresh this particular register. You can see here we know that there is timer 0 and timer 1, right? So timer 0, that is TR0 and TR1, that represent timer run bit. If timer 0 is enabled, then this bit has to be 1, right? If timer 1 is enabled, then this bit has to be 1, right? Understand very clearly, right? So that you can able to configure the timer. Right now, if we want to enable the timer 0, then all the bits has to be 0. This bit alone must be 1, right? Which means the timer run bit 0 is 1, which indicates that timer 0 is on, right? And similarly, when this is timer run bit and this timer run bit of timer 1, right? Similarly, when this is enabled, right, you can see TF0 and TF1, right? TF0 is nothing but the interrupt flag, that is overflow flag, timer overflow flag, right? We know that in every modes, whenever the timer overflows, it will enable the TF flag, correct? Right. So similarly here, it can be TF0 and this is TF1, right? So if you are using timer 0, after overflow, what will happen? This bit will be enabled, right? If you are using timer 1, then after overflow, this will be enabled, correct? And these two, right? This one, IE1 and IE0. This is nothing but the external interrupt. I already said what is external interrupt. When there is an external interrupt, that is INT0 and INT1, right? Whenever timer 0 uses the external interrupt, this one, and timer 1 uses this one, correct? This is external interrupt. And what about these two? I already explained this. These two will tell, we know that these two are external interrupt, right? And these two modes, these two bits tell you how this external interrupt will happen, whether it happens at the negative edge trigger or at level edge trigger. Sir, what is negative edge? What is level edge trigger? Right? That is whenever interrupt is happening, when there is a transition from higher level to lower level, then that is called as negative edge trigger, right? When there is a transition from higher level to lower level and the interrupt happen, then that is called as negative edge triggered. And similarly, when there is a lower level, right, when the interrupt happens at the lower level, then that is called as lower level triggered interrupt, right? So whether the interrupt, external interrupt is lower edge triggered or negative edge triggered, that will be indicated by these two bits, right? I've explained all these things before, right? Now for programming, right, you have to understand that you have to configure these two registers to make the timer work perfectly, right? So you can see this is bit 0, 1, 2, 3, 4, 5, 6, 7. You have to know the numbers of each and every bit, which is TR0, which is TR1, all those things. Similarly, you have to know the numbers of these bits, these bits, okay? Right. Now we'll start the program, right? And before starting the program, we know the timer will overflow whenever it reaches this FFFH, right? And we need to feed the count value. When you, as I said before, right? Whenever we need to start the timer, what we will do, in order to start the timer, we have to make TR0 bit 1 or TR1 bit 1, right? So it will start the timer. But before that, what we have to do is we have to give the count value for the timer so that it will start from that particular value, right? So to find out the count value, right, to find out the count value, there is a formula where this is the formula for that count value. You can see here FFFFH minus value plus 1. Whatever value we are trying to give, right, that has to be subtracted from this maximum value, right? And you have to plus 1 so that we will be able to get the count value so that we can able to program the timer, right? And you can see a good example here. If the count value is 9, right, what we have to do is I have to subtract this 9 from this FFFFH plus 1. What will give you? I will get this particular value, right? If this is the value, what I can do is these two bits are lower bits and these two are higher bits, right? We know that how to represent lower bits and how to represent higher bits. So TH0, you can see here TH0 is nothing but FF1, right? FF, and F7 is nothing but I'm saving it in lower bit, right? So TH is nothing but higher bit, right? And TL is nothing but lower bit, timer lower bit, right? And 0 represents I'm using timer 0 higher bit, I am using timer 0 lower bit, right? So this is how you have to determine the count value, right? So for any program using timers, you have to understand these basic thing, right? When my timer will work as a timer, right? What is the value of C by T? By that, you can able to find out whether it is working as a timer or counter. And then I have to configure T mod and T count register, right? Provided we have to give the count value. This is the basic for all the programming for timers in 8051, right? Now we'll see the program. So this is the question where write a program to generate a square wave of 1 kilohertz and assume that the oscillator frequency is 12 megahertz, right? So now what we have to do is we are going to generate the square wave for 1 kilohertz. Whenever we say 1 kilohertz, it can be considered as 1 millisecond. 1 millisecond, it can be converted into 1 millisecond. And whenever we say there's a square wave, right? Square wave, so we will be having a T on and T off, right? So this 1 millisecond can be considered as 0.5 and 0.5, right? So what we have to do is we have to generate the square wave at the TXT pin. Assume the oscillating frequency as 12, right? So it is like the previous question. For determining the count, what we have to do is we have to found the count value, that is 12 divided by the oscillator frequency will be the count value, right? Now as usual, what we are going to do is we are going to select which timer and which mode it has to work, right? For any programming, as I said, first thing what you have to do is you have to use mode 1. You have to use mode 1, right? And then what we will do is we will use timer 0. We will use timer 0. right? So now I'll just explain less. It's very similar to the previous program which we saw, right? Now you understand we are going to generate a square wave. Each will be having 0.5 milliseconds, correct? Right? So now you can see here, in order to select mode 1, what I have to do is mode 1 and timer 0. We have already seen that, right? I'm not going to bother about timer 1, right? So I'm going to put everything 0 here, right? Everything 0, 4 bits 0, and I'm going to use only this particular timer 0. And if it is a timing operation, I'm going to use a timer, right? So this gate bit will be 0 and C by T will be 0 because I'm going to configure it as a timer, right? And the mode will be 0 and 1, right? 0 1 will be something but mode 1. So this is how I'll be configure the T mod, right? And I already explained in previous video how to select timer 0, right? Now you have to start the timer 0. For starting the timer 0, this bit has to be enabled, right? This bit has to be 1, right? So what I have to do, 0 0 0 1 0 0 0 0, because I'm using timer 1, sorry, timer 0. If I'm using timer 0, then tr0 must be 1, right? Only that bit is 1, which means it indicates that timer 0 is running, right? That is used, right? So you can see here, to start the timer I have to configure this in such a way here, right? And to stop I have to make all the bits as 0, all the bits as 0, right? This is the same steps as I said in previous video. These three steps will be common for all the questions, right? So you can configure, you can determine which timer it works. You got to configure tmod and tcon register, right? And as I said, for 1 kilohertz it will be considered as 1 millisecond, right? And for square wave it will be 0.5 and 0.5 milliseconds. And to determine the count value, I'll divide 12 divided by the oscillator frequency, which is nothing but 1 microsecond, right? This is for one particular count, but now we have 0.5 millisecond, right? That is for T on it is to 0.5 and T off it is 0.5. So what will be my count value? It will be 0.5 divided by this 1 microsecond. So the value will be 500, which will be 1F4H. Don't get confused. Normally what we will do is we will use this particular value, but here since it is square wave, we are dividing as T on and T off. So I have to determine for 0.5, right? First I have to generate the T on, and then what I will do is I will complement that so that I can generate another 0.5. So that is why I am dividing 0.5 divided by 1 microsecond, so that the answer will be 500. The corresponding value will be 1F4H. Now you understand how to find out the count value, right? So we will be able to find out the count value to load the timer registers, correct? That is lower bits and higher bits, right? So now f of h minus 1f4h plus 1 will give you this particular value, right? Right? It's all we are going to do is we are going to use the count formula, right? That is the maximum value minus the given value plus 1, which will give you this particular value. Now from this particular value you understand which is the higher bit. The higher bit is, that is the lower bit, that is we are using TL0 and TH0, correct? Right. So what is lower bit? Lower bit is 0C. Lower bit is 0C. 0C. And what is the higher bit? Higher bit is FE. Right. Now we have done all the basic operations, right? We have selected the timer. We have selected which mode it is going to work, when we are going to start the timer, when I am going to end the timer. And to generate square wave, I need 0.5 pulse, right? That count value is also given, right? And now what I have to do is, after generating this, I have to complement that particular pin, right? So that it will generate another particular cycle, correct? Now let us see the program. You can see here, I'm going to generate the square wave in this particular pin. So what I'm going to do is, I'm just clearing this pin P3.1 clear, right? That is the TXT pin, right? Now you can see here, tmod register, you know how to configure it. The first one which we configured, tmod register. So if this value is fed to the tmod register, it will be configured to timer 0 and mode 1, right? And now you know that what is the count value of TL0 and TH0, which we found out, right? That is the value of this 500. It is feeded here. And also now what we have to do is we have to start the timer To start the timer, we know what is the value. So this value is fed into the TCON register. And now whenever this TCON register, right, whenever this TCON register, this is this particular value, it starts the timer, right? And we have already seen here when this particular bit will be enabled, correct? So here you can see here this is the same instruction which we followed in the last program. You know that this is the same operation which we done in the last program, right? So which is that is this particular timer has to be enabled until it generates a particular square wave, right? That is one particular positive pulse, right? So what we have to do, we have to wait until the overflow happen, right? When the overflow will happen, the TF flag must be becomes 1, right? So that is 0 1 2 3 4 5, that has to be set 1. So until it is 0, this bit, right, it will overloop here, right? That is jump not bit. So that is until this bit is not set, it will be jumping in the same place here, so that the timer will generate that square wave, the count value which we have given, right? And when as soon as this TCON 0.5 becomes 1, right, it discards this particular instruction and come to the next instruction. What it will do is it will complement this particular pin, which is we have already generated a positive pulse, and complementing it will give you a negative pulse here, this pulse, right, -1, right? And now we have generated a square wave. What you have to do is we have to stop the timer, right? And if we can able to repeat the same process, we can able to repeat a square wave, right? So it is the same steps which we are going to follow, right? All you have to do is you have to select the timer, we have to select the mode, right? And then we have to give the count value, right? And then we have to wait until the overflow happens, right? So that it generates the square wave, right? So today what we have seen is we have seen how to generate square wave using timer programming, right? I believe this video will be very useful for you. Thank you, my dear students.
Thank you students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும்னு நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.